So this is part 2 of how to solve financial maths question. In the first part, we were just doing the identification, which formula are we using. And we understand that depending on the situation, we ask ourselves, is it about payment or conversion? Excuse me. So, and then once we identify that it's about payment, is it about once of payment, therefore compound interest formula, or is it about many payments, therefore we have the option to choose depending on the situation. So now I will look at those questions again, but this time I want to identify what do we fill in place of the letters in those formulas depending the situation we have. Now, one thing that I want to point out, because where is the main issue? I can tell you, I know. So the main issue is with this formula. And let's be honest, that's the formula that has the biggest part of application. So I looked at it and I said, okay, let's come up with the system that will always work and has very little to remember. So let's start from the parts that are always the same, do not change. So every time when I'm filling for the value of n, I'm filling all, meaning all periods of time in particular example, so that I never have to think about it. Am I going all of them, or am I removing one, or am I removing two? All of them all the time. The same part has to do with the R value. So every time we are doing the same. It is 1 divided by 1 plus our interest rate. So those two elements are the same. Now, the only difference we're going to have here when it comes to the value of A, and I did put here the second term, so this is your term 1, this is your term 2, because in some of the situation, we need to know how is our sequence developing. So when it comes, so the main difference here is between, am I going from not having a money to having a money? So usually the investment situation, or am I going to from the situation that I have money to zero money? And that's usually a debt situation. Now, I'm not saying that that's 100%, that they cannot change the scenario, but that's usually the scenario we are faced. So if we are going from zero to, from not money to creating money, then we are looking at this part. So let's not forget that comes from my compound interest formula. That's the basis of that. So that's what we are dealing. We are dealing with this part. When, however, we are looking from having money and then going to zero money, it's the same formula, just transformed. Yeah, so it's the same formula. So this is about future money. This is about the present money. That's basically how we can look at it, because F is future money, P is the present money. But that's what I'm saying. That's the main difference. So let's apply that knowledge to these examples that we've been looking at on the previous part. Okay, so in this question we are looking, Caoimhe is repaying a loan of 20,000 over 5 years. She makes equal monthly repayments. So we understand it's not a conversion. So here I have listed all the elements depending on what formula we need. So we definitely, that's the compound interest, once off, that's the conversion. So those are the two options. And then let's get our kind of a help with all the values. So I know that is many payments, and we know she goes from having the loan money to having zero, and we know that she's making 1 month after the loan was issued, so the end. So I know those are the two options. Now, in this particular part, it's not like we have to find anything, but I want you to work with me in order to identify, let's make that slightly only bigger, to identify those elements that we have in this particular question. Okay, so the 20,000 she is taking, if I am looking at SN formula, that's the value of SN itself. If I'm looking at amortization formula, that's the value of P, present value, or the value of the principal loan you are taking. Then we are talking about 5 years, so that's about time. Now she is paying monthly, so that will be 5 years multiplied by 12 months. And again, when it comes to end, that's the same value, all periods, so 5 months multiplied by 12. Then we have the monthly repayment. So in the formula for amortization, that's my 389.56. That's what we are having here. And then the interest rate, the monthly interest rate expressed as a decimal, don't forget, so 0.0526. Now, what will happen here for the value of R? So R, always in all cases, is always 1 divided by 1 plus the interest rate, so 1.00526. Now, when it comes to this value, that is the most problematic. So like what we said, we have in this situation here that we go from money to zero money in our loan, and we are looking at the end of the period. So my first term is F, meaning what? That is that amount of money that she is repaying. So that means on top of the fraction, I'm going to have 389.56. And at the bottom of the fraction, I have 1 plus interest rate to the power of 1, so 1.00526. Now, have a go at it. I encourage you to use both of this information in both of these formulas. See, sub in all these values to your SN formula, you should get 20,000, and then sub in all these values in your amortization formula, and you should get repayment. Yeah, so that you can get a good grasp of it. Then in the next part, we have to find the amount of money that she owes at the end of the first 2 years of making repayments. So she is making 2 years of the repayments. So we are here still talking about the remaining 36. So many payments. The situation hasn't changed. She still has a loan. And then we are looking at the end of the time. So again, from our formulas that we're going to be using, it's not the compound interest, it's not the conversion. We know, let's move that a little bit. We know that that is the application we are doing here. And again, that here, nothing really changes. We have the same value. The only difference is the question is how much money she owe. So in those formulas, that means here in this part, I will be looking for P, so the principal, the loan, or here SN, that's the loan. But the rest of the items not going to change, apart, yes, the time, 36, that's what we're going to have. But here will be the same 1 over 1.0526. The same interest here will be the same. Her first repayment 38956, and then value of A here exactly the same as in that first part, that nothing changed. We are only changing those two values. We are the one that we are looking for. Okay, and then the next part here, we have to find, oops, here, got it a little bit. So find correct the annual percentage rate. So in this case, we know we are dealing with the conversion. So the part of formula, that's the one because it is from our compound interest, 1 plus I to the power of t equal 1 plus I to the power of t. And then here we are saying we are looking for 1 year, we are looking for monthly, so 12 months. So that means I have what monthly rate. So the interest rate is 0.00526 and the time 12 months, and then 1 year, and it's the I am looking for. So again, simple calculation here.